Okay. Then, first of all, I'm going to just give a brief introduction about the status of the project at the moment. Just a second. This concern what is CINE, basically Center for Innovation on New Energy, the present and the future. Basically, why I put future here just because I want to say a few words concerning that. And then I am very happy that also my colleague and also coordinator of one of the projects, Fábio Coral Fonseca, is here present with me, okay? Because as you're going to see in the next slides, he's one of the key players on the center too, okay? Here, the CINE overview, as I have most of you here already knows, and then we have shown before, today, CINE is a center that is comprised, but basically include about nearly 200 researchers. It includes faculty members, postdocs, PhD students, master students, and undergraduate students, okay? And then we are spread in 20 projects, and then supported by, financed by our sponsors. Main sponsors are Shell and FAPESP here. And then we are contributing equally on that to the support and for the center to run for the first 5 years. And then the next slide now, I just show for you a perspective, the challenge that we face, and to provide for you to say a good idea what is the challenge that you have to face for the next years to come. First thing is here, CINE is here, okay? And here there's a budget that is, so to say, by our sponsors, FAPESP and Shell, of $20 million that is added to that center, to nearly 200 researchers. Of course, we also have some additional grant that is coming from here, that is putting here together, that are, to say, fellowships from FAPESP, fellowships from CNPq, and from CAPS. Even that they are struggling, but all of them are supporting our center very strongly, okay? And then this budget is expected to run for the center to run for the first 5 years. One of the core expertise on the center today, as you can see, you understand, basically is material research, design, discovery, and development of materials for new energy applications. Basically, this is our goal. And when you say that, you have to be very careful now how to face our challenges. Because when you say material research, does not mean everything on material research, but means what is important for our sponsors too. On that sense, there's some challenge that I want to mention. Here's the following. We have to build up a scientific culture that stands longer than 10 years, because 10 years is the expectation that the running time for our center for 5 + 5. Means how to build up a culture, scientific culture that we stand together, scientific collaborations and going on beyond of that 5 years. This is what you keep if the center is a success or not. Why? Because once the budget finished, the center is dissolved. It means the center the binding was only the money, and we have to go beyond of that. Another point is we are, as every one of you here today have traveled 100 kilometers to be here, basically are within the radius of 300 kilometers maximum. We have to build up a scientific integration among the localized groups, because there are groups here, many of you here today are from São Carlos, but many of you are from the São José dos Campos, from Campinas, from São Paulo, from Ribeirão Preto, and so on, okay, from Diadema too. Means we have to build up, to say, an integration among all of us here, but beyond of that, we have also to build up integration with our partners that are working the experimental side of every project we are doing here. And this one, a very important point that we have to say here, this concern, that is the following. When one of our students here that belongs to this division goes for a workshop, means can be in São Paulo or the annual conference of CINE, and he says, I work with methane conversion. He should know that this methane conversion is connected with the division led by Fábio Coral Fonseca. Maybe you can say, oh, but I don't collaborate with them. But you have to see how your project is connected together on those structure. Means should not be isolated. Okay, I work alone on that project. Not. This is part of a common, large effort involve a lot of number of people. This is very important. And for last, one upon that very important challenge is the scientific alignment with our sponsors. Okay, now come a very, very important point here. Means, okay, we proposed a project with FAPESP. Okay, is to say well recognized as a good one, was selected. Okay, then we were doing good science. Fine, the goal was on. However, we have Shell too. And of course, as an enterpriser, they want to have some return from that. Their investment we have to develop some knowledge that can be useful for them. And then this one is connected here. Can we do material science research in every topic that we wish? No. We should align our expectations with Shell expectations. We should align it. Oh, but I'm going to publish a very important paper on that topic. Oh, congratulations. But maybe it's not for our interest. We have to align those researches from the alignment. And this is important because then we need to be closer with our sponsors. And this requires a large effort to exchange information and to see what's important and not. I will give just an example. When Shell select the Division IV to say, you're going to focus on the conversion of methane to methanol. This is the focus of the division, maybe, for most of the case, as Fab can confirm later on, because they have different partnerships in different universities around the world. They are focused on different, research concerning methane too. Means the following: we are one part of a big investment portfolio inside of the enterprise of Shell. Means we are not just one doing research for them. There's many research institutions, many partner groups that are working with them for many years. Then because of that, we have to, very important, we are concerned with the scientific alignment with our sponsors. This is a key step here. We cannot do just, we are going to do whatever we wish as a research, because I publish very good papers, as I do a thematic project, and we follow up doing that for next 5, 10 years. Unfortunately, we cannot do that. Okay. And then, to ensure that we are following those challenges and to try to fill the gap, to fulfill those challenges, we have a group here of 4 PIs, includes myself and also Fábio Coral Fonseca is here too today. I'm very happy once again. And then you have here also Ana Flávia Nogueira from Unicamp, that she leads the Dense Energy Carrier Division, DEC. And then you have Professor Rubens Maciel Filho, that is also director for our hub, and answer for our institute, and also lead the Advanced Energy Storage, and Fábio's methane converter to products. As you can see here, those divisions, experimental divisions, they are here, okay? And then we have a horizontal division within CINE, that's the Computational Material Science and Chemistry division, in which we focus on similar topics their experimental divisions are addressing, okay? But from the computational point of view. And then we have to align, because what we are doing here, we have to build up connections here. We have some cases that already started, but once we have completed 1 year already of the project, we have the expectation that those alignments can build up faster. Means the following: every researcher, every faculty member that is inside of our division, that work on this division here, we have the expectation that he build up at least 1 collaboration with experimental teams. At least 1 collaboration should be built up. Means we have 12 faculty members, 11 faculty members at the moment. We should have at least 12, 11 collaborations built up with experimental divisions. This is the only way that we can be successful together. Because alone, we cannot do it. Means we have to make an effort to try to connect in this direction, and basically there's no way to avoid it too much. Second point here, this is the structure of CINE. And then I was discussed with Fábio this morning, how on lunchtime now, how it works. Basically, we have here the Joint Steering Committee. The Joint Steering Committee for our center is composed by 2 representatives from FAPESP and 2 representatives from Shell. Basically, are the ones that decide if the center should continue or not, it can be dissolved or not at any time they wish, as they have the power for that. Then we have here Executive Committee that's composed by 4 PIs and also by 1 deputy director is a representative from Shell that is overseeing the interest from Shell and follow up it inside of our structure. Then you have a scientific committee here. And then you have here an international advice board. Basically, we have 5 well recognized experts in different fields that you are working here. And then the joint steering committee, they meet every 6 months at average, and the scientific committee every 2 months at average, and the executive committee every month. Means every month I go to Campinas or it's online meeting. But every month we have to have a meeting to discuss how the divisions are going, where we might have some small problems, or how you solve it, how to adjust to fulfill that our challenge that was mentioned here before, we fulfill it. And then we have to constantly verify on that. And then the National Advice Board, you meet every 12 months. And we have one Education Dissemination Knowledge Coordinator that Professor Adilson from FISCAR. We have also Technology Transfer Coordinator that is now followed up by Professor Rubens, Human Resource Manager, and the Executive Manager here. And then here we have 4 divisions. Almost all of you here are part, most of you are part from Division 4. This is CINE-CMSC division. And then basically all the divisions are here, and then all those executive committee meetings here are organized in the way that our scientific divisions employ same standards to try to fulfill that the center, that we are a center, okay? And then here we have workshops that's organized by each division every 6 to 12 months, depending on each division, how they are, the integration scheme, because some divisions, they are more decentralized, more delocalized in different institutions. Some divisions are more concentrated in one place. And then because of that, those workshops can happen at a different time scale because they have more like a short, regular meetings almost every month. And then this structure can follow up very well. And then this is the structure from CINE and how it works at the moment. Of course, as a center that you are creating, it is a 1 year that I have run already, we have to say we are constantly doing adjustments on how the structure should work because to try to get the best from it. And here is how we work with the scientific alignment with our sponsor. Basically, we have 4 representatives from Shell, because the Shell technical champions. The case most of you here already know, Dr. Idranil Rudra, he's from the Bangalore, from the Shell Center in Bangalore, Technology Center in Bangalore. And then we have Ryan Stephens from Houston. We have Flavia Cassiola also from Houston too, and Sunny from Amsterdam, okay? And then each one of them are responsible to follow up one of the divisions. In the case of the new our division, Flavia Cassiola follow up with the division with Ana Flávia Nogueira, Ryan Steve, Professor Dr. Rubens Maciel, and Sunny with Fabio here. Okay, it means all those 4 guys are responsible to follow up, to say basically a monthly, every month a meeting, sometimes more often, sometimes every 2 months, it depends on what is happening within the center, if you have more reports or more deliverables, and then you have to report and then to follow up. For example, if you want to make a decision, for example, some 4 months ago, we make a decision that we're going to start a batteries project. Okay, we should focus on flux batteries or lithium-air batteries or different topics. Then, okay, or sodium batteries. Then we discuss with them and say, oh, sodium batteries maybe is the way to go because of that and that and that. Fine. Also because lithium batteries are widely studied. I mean, it does not make sense to put too much effort on that. And then we decide to go for sodium batteries. And those discussions are follow-up with Dr. Idranil. Means at that regular base. Okay, and this helps us to how to move on. Okay, one point that is very important here that most, I think, with few exceptions here, maybe Fabio and also Professor Manuel Carrillo, they are working the experimental side, but most of us here are working on the theoretical material side point of view. That's very important here. This slide gives for you the intention that how we should move to say how you are moving and how you should to say stress to move forward. Is concerned a modern view of material science, basically to develop develop materials for new energy applications. For example, we have to combine simulations, experiments, theory, let's say brainstorms when you track the theory and try to move it forward and if you have to develop a bit further or not. But we have to build up an approach in which we work together, a partnership. Of course, it's always a challenge to work in a partnership experimental because the time scale is different. Sometimes the experimentalist takes a long time to build up the sketch, to build up the setup. But once it's done, it's few months produce ton of data. And for us, unfortunately, we depend on the speed of the Intel processors. And then we have to plan it very well ahead, how to start it. because sometimes, we're doing faster, but this fast is just, our speed is almost constant. There's no way to increase it too further. Of course, you can have more computer power, but sometimes it's not, most of the cases, not available, okay? But this is one important thing that I mentioned here before. We need that everyone on the CMSC team, we should build up a partnership with experimental groups. Without it, it will be very, a challenge to fulfill our goals without those partnerships. Because the success, we have to look at the success of the center itself, because the center is one project by itself. It's a big project, $20 million for 5 years project. Means it's not just a success, individual success of individual ones, but we have to look at the full center, and this is very important for us for the future. Of course, I have to tell it many times because I have to convince my colleagues too. Okay, this is why I try to stress it once again and once again. And here, for example, I show this picture. I know I have some update here. Basically, follow here. I will show the computation techniques that is available in this room here. Go for quantum mechanics. Maybe here a lot of people doing quantum mechanics. They have atomic model and use force fields. Basically, use lumps, grommets. We have 2 hands-on in this workshop dedicated to the grommets training and also lumps too. Means then you have mesoscale approaches and continuum modeling. It goes from finite size elements, diffusion equation, computation, fluid dynamics. Means all those things we have to connect them. They cannot work separated pieces. They must work together in the way to address problems in material science. I'll give just an example here. We have here perovskite-based material for solar cell applications. It's one of the big projects that we have. Inside of our division, we have one project. On the deck, led by Ana Flávia Nogueira, we have one project too, dedicated to the perovskites. What I see here is the following. Those type of cases here, we have to use quantum mechanics. We have to move to atomic modeling, maybe coarse grain, whatever, and continue approach to address this problem. We have to not look, we have to combine expertise. Without those combinations, we cannot succeed to make a very good, contribution to this field. And doing that, by contributing different techniques, we are going to move in this direction. The same thing when you want about methane conversion. We have the same situation. We have to combine quantum mechanics, atomic modeling. We have here, for example, in that case, Gustavo Troiano and Nata Alpa working on the methane conversion using zeolites, and also copper site, active site, is confined in zeolites. In this case, this direction. But you also have the ideas also to start on the serial oxide materials, basically with different approaches too. Means what I mean here that's very important, that we have to connect our expertise together to combine that. For example, we have some like here, we have like Eudes, and also Leonardo, Luis Gustavo, unfortunately is not present here, work on the atomic modeling. We have also to see, okay, can you also look on the quantum mechanics? No, it's hard for us, sure, but then we have to combine now with those ones that are doing Hex expertise in quantum mechanics. Unfortunately, I don't put here, but it's a very important block that we have to put here, is machine learning techniques. That in our project, we have Ronaldo and Marcos Quiles. They are the machine learning techniques have the potential to contribute for all those topics here. All those techniques can be complemented using machine learning techniques to address and analyze a large amount of data, and from that on to build up models which can improve the existing ones. Means we have to move in this direction. When I say this, it's very important, for example, many times, for example, the students have to move forward. You have to ask for your supervisors, okay, can I do that too? It's possible to adjust my master thesis or PhD thesis, I move in this direction, because it's very important. One point is important here that I want to mention the following. We can organize as many workshops as we wish. However, without the commitment of everyone, it's just a spend of money. Means we have to make the workshops to integrate the people, but it's not integration itself. This is just a knowledge dissemination among all the students. But we have to make the commitment that we want to move in this direction, but together. And this commitment is what is going to make the difference for us for the future. Means the commitment to collaborate, the commitment to integrate the experimental and to see what problems they have and how can you help. And this is the most important word here I say today. The commitment to make the center even more stronger inside, combine all of those techniques. And then I just give an example here. For example, what I want to mention here, just example, in case of perovskite. I just pick up one example, the rise of perovskite materials. As you can see here as a part of this slide, the perovskite materials are here. Based in the last decade, they have a huge increase in the efficiency of solar cells based on perovskites. Basically, methyl ammonia, lead, like iodine materials for development of the solar cell have increased steadily in the last 10 decades. Okay? Okay. And here we have several questions here. For example, lead is toxic. You want to replace it by different cations that have, to say, similar efficiency. Also has a problem with stability, because under water vapor or different materials, they are very unstable materials for some applications and so on. And then we have some experimental techniques here, experimentals that are conducted in the group of lead by Ana Flávia Nogueira in Campinas. And then what they are the characterization of those materials, look at different structures, synthesize new compositions, new possibilities, try different cations, different combinations like 2D perovskites, 0D perovskites, 1D perovskites, and so on. And then you have here the theoretical approach when you are addressing the similar materials they are doing in the laboratory now, as well as try to understand how to replace, what are the candidates for the cations, and also looking for new structures, like, for example, 2D structures. This one from the theoretical point of view. Okay, what I want to say here is I just give this example. Every one on this project that are based on the computational material science and chemistry, we have to follow similar example. We already move on 1 year of the project. Next year, we are going to reach 18 months. And then, basically half of the time when you have a very big evaluation, that's right, Fabio, the month 36, in the third year, in which we have to really show that we deserved to continue as a center. Means, and to show that we need to convince, we need really to show that we are doing really be useful for the center. And this is very important. We have to show that as a computational material science unit, we are used for the center. But on the side, okay, but computational material science is useful because it's cheaper, and then you can help a lot of material science development. Material science, computational material science is not so cheaper. Okay? For example, our cluster is just nearly arriving, is a 2 million reais machine. Okay? We make the accountability, we make the accounts, how to support this structure of the computational data center here in São Carlos. It's going to consume us to keep it running, energy, air conditioner, everything, maybe more 2 million reais. Okay? It costs. And this is the University of São Paulo is happy to contribute with that, but it's a highly cost. Means computational material science is not so cheaper. Means we cannot do calculations just because, okay, I like this calculation, I will do it. No, we have to make calculations if they are useful, if they have a low computational cost, and they have a good return to help experimentalists understand their result. And these include all the remaining experiments. And here I have just few conclusions, just a few remarks. For example, we should continually improve our work in administrative and scientific structure towards a world-class center. Because we are not going to build up a world-class center, but just by setting the first day, the structure, and keep it constant for 10 years. No, we need to make adjustments year by year until you reach a level in which you are recognized as a very important center. Scientific integration, knowledge dissemination is crucial among the CINE members. Which means we have webinars every month now. Every member from the division will give a talk. For the next 12 months, it'll be 3 members per division. Okay, it's very important that everyone follow those webinars. In the last one, we have only 17 members looking it online at the same time that it was happening. Compared to 200, there's a lot to improve. Of course, the movie is there. Everyone can see it later on. But we have to make a commitment that we have a committed with this center. That's very important. Webinars, workshops, conference play a crucial role. Once again, here I emphasize that it plays a very crucial role to integrate and to disseminate knowledge among the members. However, the commitment to build up a scientific collaboration that stands for years among PIs, co-PIs, and associate investigators to solve real-life problems in new energy applications. This one maybe is the most important thing to happen. The commitment that we have to that particular, to say, project we are involved in. Means the scientific integration is very important. The workshops, webinars, they provide the dissemination of knowledge, but we have to make the commitment that we want to push in this direction. The scientific alignment with CINE goals. And here is very important. We have constantly to keep in mind that we have to be aligned our expectations with our sponsors year by year, semester by semester, because different targets can change. But we should focus on material research for new energy application aligned with our sponsor. Means we can publish very important papers, okay? As I will say, for example, I will mention one center that I listened in Amsterdam just in July. We could pick up all this money, $20 million, and put in just a single project, methane. Just methane, I use methane as a simple example. And then in 10 years, we could have a very important catalyst. Means very big news. But it's only this that matters for us. No, there's a lot of things that matters. I mean that you have to put the right, you have to make the right, to say, provide the amount of money from the right project to have all them move on the same direction. At the same time, we should not spend our effort in some directions that are not important for us. Adjustments along the years are crucial to mature the project and improve alignment with the sponsors. And this is very important. I mean, when you try to adjust some project, we make some changes. I use a sentence here that Brito says for us a few times, like to say almost the beginning of the project. The project is defined, but then they are not written in stones. Means we can adjust it, we can improve it as much as we can, as we need it, but we need to align it with our sponsors and also our experimental partners. Okay, that's very important too. Okay, I'm doing some simulation in this direction. How does align with the experiments that are conducted in the lab? Are you simulating realistic materials or some material that just exists in our mind? Okay, this is very important. We have to push and always make those questions. Okay, with this slide, I will just conclude my presentation from the open workshop, and then I open for questions and so on. Okay, thanks for your attention.